Okay, this whole section I've been talking about skewed, and we've used those words before, right? Right skewed, left skewed, because it's where that tail is looking at the data. Now, here's where we're going to use the mean and median and talk about how that relates to our distribution shape. All right. So if this is a nice, sweet, oh, that's terrible, isn't it? A nice, sweet little bell curve there. That means your mean and your median line up. So I'm going to scoot back here just a little bit. Remember, I was talking about that over here. 79.5, 70, 79. I knew I was clicking the wrong thing. 79, 79.5. See how close those are? And I said, oh, that was kind of like a bell curve. Now I'm going to scoot it over again. That's what we're talking about. If the mean and the median line up, then I have a nice symmetric curve. Whenever they're really close to each other, that's symmetric. And it's roughly equal. So we had 79 and 79.5. That's cool. That's cool. It's okay to have that. It's roughly equal, or even within 1 point of each other. If it had been 78 and 79, that's still super close. We're okay with that. All right. If I have this skewed to the left. So remember when we've talked about skewed to the left before over here, this is where your tail is over here to the left. That's because we have more data. So more of our data is over here in this tail, in that wing of it. If that's where more of my data is, we saw that before, that's going to pull my mean. And they're not going to line up. So there's my median, and that's why it's skewed to the left, because it's pulling the mean to the left, and that's why it's skewed left. Cool, right? See, it's all starting to come together. The tail is over there. I have more data over there, and it's pulling my mean that way. We saw that in that last example with that phone call of 48. That pulled my data to the right, and that's what made it skewed right, because it pulled that mean in that direction. And then that's the key to that. If I have this right tail, wherever that tail is, that's where all my data is, and that's where it's pulling it in that direction. That's what makes it skewed right, and it's pulling my mean to the right. Cool, right? Same thing. Look for the tail. It's skewed right because I have a right tail. And it also pulls that mean that way. And a mean will be larger than the median, where if it's skewed to the left, the mean will be smaller than the median. And notice it says the word substantially, because it's not talking about like 1 or 2 points. It's saying, oh, look, it's really pulling that data. Just like over here, I'm going to scoot this up again. Notice this is really pulling the data. So you tell me, if this is 7.25, this is where my mean is, and this is where my median is. Which way am I skewing? Yes, so because my mean is to the right, this is going to be skewed to the right because it's to the right of my median. And so this data is going to look like this. See, it's all coming together now, right? We're seeing these distributions, how the mean and the median work with it, and we're getting these pieces of data to where we can work with it. All right, now here's the deal. This is 50 pieces of data. We're not going to do that bad boy by hand. We're going to find the mean and the median. I'm not about to be writing all these out at this point, just because it would take forever and your video would be super long, and I'm not going to do that to you. So you can do that on your paper. And so then you can see how that plays out. But for our intents and purposes of this particular problem, please know I'm not going to give you a problem with super crazy amounts of data that you're going to have to do this with. All right. So rest assured. But for this one, because I want you to see, if I'm finding my mean and it tells me that this is a sample, 50 samples of birth weights in these babies, so that I'm using X bar. If I were to sum up my data value and divide it by 50, I'm going to get 7.488. Now you can do that on your calculator, and we're just going to go to 2 decimal places so that you can check it. It's always good to practice, because that's how you learn math, is practice. For time's sake, I'm not going to do all that. And I'm telling you that our median is 7.35. All right, so with this set of data, my mean is 7.49. My median, if you were to line all of those out, is 7.35. All right. Now, describe the shape of this distribution. I'm going to squeeze this down here a little bit. What do you look at? 7.49. And look at all these pieces of data in here. 7, 8, 9, a little bit of 5, a small little fellow. Right? Okay. How would you describe the shape of the distribution based on the fact that my median is 7.35 and my mean is 7.49? Yeah, those are really close, right? Those are roughly equal. We're talking like obviously far less than a pound, like a tenth of a pound, right? Super small amount of difference between those two. Those are roughly equal. So then what would we say about this data? That it would be symmetric. Good. Because the mean and the median are close. Oops, I forgot my L. Let me go back. Close. The distribution is symmetric. Is symmetric. All right. Which measure of central tendency better describes the average birth weight? Okay, yeah, so they're super close, right? So it's kind of a toss-up at that point because I'm not skewed one way or the other. I'm not trying to look at my data here. If I'm skewed, then median is always the best way to go because it's closer to the majority of my data. Right, but if I'm looking at this, then we go with the mean. All right, so just rule of thumb, because, my thing moved on me there. Because the data is symmetric, we go with the mean. Symmetric, we go with the mean. And it's a sample, so I'm just putting X bar in there. Nice, mean, median, and mode, and how it plays with our statistics. It's getting exciting, isn't it? Oh, there's more to come, my friends.